A dialogue between quantum mechanics and Buddhism, Part 3, on independence. Quantum mechanics introduced three major conceptual revolutions. These revolutions not only overturned some of the most fundamental assumptions of the classical physical worldview, but also unexpectedly resonated with certain ideas found in Buddhism. The three central concepts are objectivity, reality, and independence. Quantum mechanics' reinterpretation of these concepts represents a profound challenge to the logical framework of classical physics, and to the conventional understanding of science that people have held for centuries. It may even be described as a fundamental overturning of that worldview. In the previous two episodes, we discussed the concepts of objectivity and reality. In this episode, we turn to the third major concept, independence. 1. Modern physics, the EPR paradox and the Foucault pendulum. In the classical picture of physics, objects were not believed to possess any clearly defined intrinsic connection with one another. Motion and change were understood primarily as the results of external forces, and physical phenomena were thought to be driven by those forces. Einstein's general theory of relativity disrupted this isolated picture of reality. The mass of an object affects the entire field of spacetime, which in turn alters the trajectories of other objects. Things could therefore no longer be regarded as entirely independent and unrelated. With the development of quantum theory, physicists discovered that, at the microscopic level, an entity could no longer be understood as an isolated object. Instead, it had to be understood through the interaction between experimental conditions and measurement outcomes. Physical phenomena arise from exchanges and interactions among particles. The world thus began to appear as a dynamic system of mutual dependence and coordinated interaction. Quantum theory revealed a fundamental feature of the universe: we cannot divide the world into independently existing elementary units. When we penetrate deeply into the microscopic realm, nature does not present us with separate building blocks. Instead, it presents a network of relationships through which the parts constitute the whole, a network from which even the observer cannot stand entirely apart. This universal and profound interconnectedness is vividly illustrated by both the EPR paradox and the Foucault pendulum. 1. The EPR paradox. In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen proposed the famous EPR paradox. They intended to demonstrate that quantum mechanics was incomplete. Instead, subsequent developments repeatedly confirmed the extraordinary precision and depth of quantum theory. The thought experiment may be described as follows. Suppose a stable particle breaks apart and produces two fragments, A and B. According to Heisenberg's uncertainty principle, we cannot simultaneously know both the position and momentum of either A or B with complete precision. However, because momentum is conserved, measuring the momentum of B allows us to calculate the momentum of A. Likewise, because the two particles move symmetrically away from the point of separation, measuring the position of B allows us to infer the position of A. An experimenter may freely choose whether to measure the position or momentum of B. In itself, this may not seem especially remarkable. The real difficulty emerges when A and B have traveled in opposite directions and are separated by an enormous distance, perhaps 200,000 light-years. Under those conditions, the idea that a measurement performed on B could immediately affect A becomes highly unusual. According to special relativity, no signal or physical influence can travel faster than the speed of light. During the time required for light to cross the distance between the two particles, A should have no possible way of knowing that B has been measured. There should therefore be no form of instantaneous action at a distance. Yet experimental reality does not conform to this expectation. Although no ordinary physical force appears to pass between A and B, the two particles behave as though they had somehow coordinated their responses in advance. Their behavior remains strongly correlated. Einstein found this coordination deeply troubling. He could not accept what appeared to be a ghostly form of long-distance cooperation and famously referred to it as spooky action at a distance. Einstein believed that every element of physical reality should be locally situated within the individual particle. This conviction came into fundamental conflict with the non-locality suggested by quantum mechanics. Later, Bell's inequality provided a theoretical means of distinguishing quantum mechanics from local hidden variable theories. Experimental tests increasingly favored the predictions of quantum mechanics. In 1982, Alain Aspect and his team in France conducted a landmark series of experiments. Under carefully controlled conditions, they showed that subatomic particles moving in opposite directions could remain correlated even when separated by considerable distances. A change in the measurement setting applied to one side was reflected in the statistical behavior observed on the other. The intrinsic connection within the microscopic world thus received powerful experimental support. 2. The Foucault pendulum. While the EPR experiments revealed a hidden relationship among microscopic particles, the Foucault pendulum brought the question of interdependence into the macroscopic world. In 1851, the French physicist Léon Foucault designed a large pendulum to demonstrate the rotation of the Earth. The pendulum consisted of a 28-kilogram weight suspended from a wire approximately 67 meters long. A bed of sand was placed beneath it. As the pointed end of the pendulum passed over the sand, it left a visible trace, recording the gradual change in the pendulum's plane of oscillation. For an ordinary pendulum observed over a brief interval, the plane of motion appears approximately fixed. The Foucault pendulum, however, is observed from the rotating surface of the Earth and therefore reveals the effects associated with that rotation. The results are clear. In the northern hemisphere, the pendulum's plane of oscillation appears to rotate slowly clockwise. At the North Pole, it completes one full rotation in approximately 24 hours. The rate decreases as the pendulum approaches the equator, where no rotation of the oscillation plane is observed. In the southern hemisphere, the direction is reversed. The experiment provides a direct and elegant demonstration that the Earth rotates. Yet another interpretation raises an even more intriguing question. Suppose we align the Foucault pendulum with a distant star. If the star appears fixed, the pendulum's orientation seems to remain aligned with that distant reference even as the Earth turns beneath it. If the apparent position of the star changes, the alignment between the pendulum and the star also gradually changes. In this sense, the behavior of the Foucault pendulum does not appear to be defined solely by its immediate local surroundings. Its frame of reference seems connected to the distant stars, the galaxy, and perhaps the universe as a whole. More cautiously stated, the experiment invites us to consider whether local inertial behavior may be related to the large-scale distribution of matter throughout the universe. This idea is associated with Mach's principle. According to one formulation of the principle, the inertia of a body arises from its relationship with all other matter in the universe. Local inertial motion may therefore be understood in relation to the average motion and distribution of matter on a cosmic scale. The substance of mechanics, from this perspective, lies in the relative motion of matter rather than in motion against an absolute and independent space. The Foucault pendulum therefore suggests that relational dependence is not confined to the microscopic world of particles. It may also be relevant to the structure of the universe on the largest scale. Interdependence, in this view, applies to both the microscopic and macroscopic worlds. 3. Bohm's holographic analogy. How, then, should we understand this interconnectedness that seems to run through all things? The physicist David Bohm proposed a striking analogy. Perhaps the universe resembles an immense and infinitely detailed hologram. A hologram is a three-dimensional image produced through laser interference. One laser beam illuminates an object, while another interacts with the reflected light. The resulting interference pattern is recorded on a photographic medium. When the recorded pattern is illuminated again, a three-dimensional image appears. The most remarkable property of a hologram is that the whole image is distributed throughout every part of the recording. Suppose a hologram of a tree is cut in half. If one half is illuminated with a laser, the complete tree can still be seen, although the image may contain less detail. Even if the hologram is divided repeatedly, every fragment continues to contain information about the entire image. This property, the whole being contained within each part, provides a powerful model for interpreting the phenomena associated with the EPR experiments and the wider relational implications sometimes drawn from the Foucault pendulum. Each part reflects the whole, while the whole is manifested within every part. Modern physics therefore presents us with a radically different picture of the world. The interconnections among things do not appear to stop at the boundary between the microscopic and the macroscopic. Nor do they necessarily conform to a simple division between matter and mind. The universe resembles an immense web of overlapping and endlessly interacting relationships. All things depend upon one another and participate in the coordinated functioning of the whole. Because of this deeper interconnectedness, the local may reflect the global. The poet's vision of seeing a world in a grain of sand no longer appears merely as a romantic fantasy. It may also be understood as an intuitive expression of the relational structure of reality. The quantum entanglement revealed through EPR-type experiments forces us to acknowledge that microscopic particles may display correlations that exceed the expectations of classical physical intuition. The Foucault pendulum, on the other hand, reminds us at the macroscopic level that local inertial motion may be understood in relation to the wider structure of the universe. Together, these examples point toward an important insight of modern physics. Information about the whole may sometimes be inferred from a local phenomenon because no local part exists in complete isolation. Every part is connected, directly or indirectly, with other parts of the whole. Each part therefore both contains traces of the whole and depends upon the whole for its existence. As Werner Heisenberg observed, we cannot simply decompose the world into independently existing objects. What we encounter instead is an interwoven network of relationships. The world appears as a complex structure of events in which different connections alternate, overlap, and combine, eventually producing the form of the whole. 2. Buddhism, the infinite dependent arising of the Dharma realm. The Huayan school of Buddhism, also known as the flower garland or Avatasaka school, places particular emphasis on the mutual dependence and interpenetration of all things in the universe. Drawing upon the Avatasaka Sutra, the school developed a body of thought known as the perfectly interfused and infinite dependent arising of the Dharma realm. In simple terms, the world is understood as an infinite network. Nothing exists in isolation. Every phenomenon is intimately connected with every other phenomenon. Things mutually contain one another, bring one another into being, support one another, and coexist without obstruction. Its central insight can be summarized through two concepts: mutual identity and mutual interpenetration. Mutual identity. Mutual identity means that all things share the same fundamental nature and cannot ultimately be divided into completely separate realities. The relationship between waves and water offers a simple analogy. A wave is water, and water manifests as waves. They share the same underlying nature, and neither can exist independently of the other. At the level of fundamental reality, this illustrates the common ground of all phenomena. Mutual interpenetration. Mutual interpenetration means that all things contain and permeate one another. Imagine two mirrors facing each other. Each mirror contains the reflection of the other, and within each reflection appear further reflections without apparent end. At the level of function and relationship, this illustrates how things influence, include, and reflect one another. To explain mutual identity and mutual interpenetration more fully, the Huayan tradition developed two complementary systems: the 6 characteristics and the 10 mysterious gates. Together they are often called the 10 gates and 6 characteristics. 1. The 6 characteristics. The 6 characteristics teach that every phenomenon simultaneously possesses 6 aspects. Although these aspects may initially appear contradictory, all 6 are considered valid at the same time. They are arranged in 3 pairs. The first pair, universality and particularity. Universality means viewing something as a complete whole. Particularity means viewing the individual parts that make up that whole. Consider a house. When you stand outside and say, "This is a complete house," you are seeing its universal or total aspect. You perceive the whole. When you enter the house and observe that the living room, bedroom, kitchen, and bathroom each have different forms and functions, you are seeing its particular aspects. You perceive the differences among the parts. The Huayan school teaches that both perspectives are simultaneously true. The building is one complete house, yet each room also has its own distinct characteristics. There is no contradiction between these two views. The problem in ordinary thinking is that we often focus exclusively on either the whole or the parts. We forget that both are different dimensions of the same reality. The second pair, identity and difference. Identity refers to what the different parts have in common. Difference refers to the distinct characteristics of those parts. Again, consider the house. The living room, bedroom, and kitchen differ in their appearance and function. Yet they share one common purpose: each contributes to the existence and functioning of the house. That shared purpose represents identity. At the same time, the living room is not the bedroom, and the bedroom is not the kitchen. Each has its own characteristics and role. That represents difference. Huayan teaches that identity and difference do not contradict one another. Difference exists within identity, and identity exists within difference. Attempting to erase all distinctions is a mistaken view. Attempting to sever all relationships is equally mistaken. The third pair, integration and disintegration. Integration means that the parts come together to form the whole. Disintegration, in this context, means that the parts remain in their own proper positions and preserve their distinct functions. The living room, bedroom, and kitchen come together to constitute one house. This is integration. The parts combine to produce the whole. Yet the living room remains a living room. It does not become the bedroom. The bedroom remains the bedroom and does not become the kitchen. Each part maintains its own identity and position. This is disintegration or differentiation. The parts remain distinct. The Huayan school teaches that integration and differentiation occur simultaneously and do not obstruct one another. In fact, the whole can exist precisely because its parts preserve their distinct functions. If the living room, bedroom, and kitchen all became indistinguishable, the house would cease to function as a house. In ordinary language, universality concerns the whole. Particularity concerns the parts. Identity concerns what the parts share. Difference concerns how the parts differ. Integration concerns how the parts come together to form the whole. Differentiation concerns how the parts retain their proper positions. Every phenomenon possesses all 6 characteristics simultaneously. None can be omitted. The point is that we should not cling exclusively to any one aspect and mistake it for the whole truth. To understand something fully, we must be able to see it through all 6 dimensions. 2. the 10 mysterious gates. If the 6 characteristics explain the internal structure of a phenomenon, the 10 mysterious gates explain the relationships among phenomena. The central principle of the 10 gates may be expressed in one sentence. All things in the universe mutually contain and reflect one another, arise together, and coexist without obstruction. The first gate, simultaneous completion and mutual correspondence. All things in the universe exist fully at the same moment and correspond with one another. There is no absolute sequence in which one must first exist before another, nor is there an ultimate hierarchy of primary and secondary. In simple terms, it is not necessarily the case that one thing must come first so that another may follow, or that one thing is inherently more important than another. All things participate simultaneously in bringing the whole into being. Consider a symphony. The violin, cello, piano, and flute sound together. No instrument must wait for all the others, and no instrument is absolutely superior to the rest. Together, they constitute the musical work. The second gate, the unobstructed freedom of the vast and the small. A phenomenon may be vast and small at the same time. Greatness and minuteness do not obstruct one another. In simple terms, a universe may be contained within a grain of sand, and a universe may be condensed into the smallest point. The large and the small may contain one another without contradiction. This may sound impossible from the standpoint of ordinary experience. Huayan thought, however, teaches that size has no fixed, independent, or substantial reality. Large and small exist only in relation to one another. A famous passage from the Avatasaka Sutra expresses this idea. On the tip of a single hair appear the jeweled lands of the Buddhas, seated within a particle of dust, the great wheel of Dharma is turned. The entire world of a Buddha may appear upon the tip of a hair. The third gate, the mutual containment of the one and the many without loss of distinction. The one can contain the many, and the many can enter into the one. The one and the many mutually include each other while preserving their distinct appearances. A mirror can simultaneously reflect every object in a room. A single drop of seawater contains the same basic chemical constituents found throughout the ocean. The one is present in the many, and the many are present in the one. Yet the one does not literally become the many, nor do the many cease to be many. The fourth gate, the free mutual identity of all phenomena. All things mutually constitute and imply one another. Each exists within the others, and there is no absolute boundary of complete independence. In simple terms, you and the universe mutually participate in each other's existence. Without sunlight, air, water, food, parents, society, and countless other causes and conditions, there would be no individual you. Your existence therefore includes the existence of the wider universe. At the same time, the universe as it exists also includes your presence within it. There is no absolute wall between things. They mutually penetrate, support, and contain one another. The fifth gate, the simultaneous completion of the hidden and the manifest. Within the same phenomenon, what is visible and what is hidden are both real. The manifest and the concealed do not obstruct one another. Consider a coin. When you see the front, the reverse side is hidden. When you see the reverse side, the front is hidden. Yet both sides exist at the same time. What is visible and what is concealed are equally part of the coin. The same principle may be applied to the universe. What we can see and perceive represents only a small portion of the totality of reality. What remains concealed may be no less real. The sixth gate, the peaceful coexistence of the infinitely subtle. Within the smallest and most subtle phenomenon, countless other phenomena may be contained, all coexisting without confusion or obstruction. In simple terms, innumerable worlds may exist within a particle of dust, each operating according to its own order. A contemporary analogy would be a small digital storage device capable of containing enormous quantities of information. Many different files can coexist within it without interfering with one another. The seventh gate, the realm of Indra's net. The entire universe resembles the infinite jeweled net said to hang in the palace of Indra. Each jewel reflects every other jewel in the net. Within each of those reflections, all the jewels are reflected again. Within those reflections are still further reflections, continuing endlessly. This is perhaps the most famous and beautiful metaphor among the 10 mysterious gates. A modern analogy might be a photograph on a mobile phone. The image contains information about the entire scene at the moment it was captured. Within the scene, the eyes of each person may also reflect the surrounding environment. Within each reflected image appear further images, continuing layer upon layer. The universe is like such a network. Every point reflects every other point. Nothing exists in complete isolation, and nothing is insignificant. The eighth gate, revealing the Dharma through particular things. Through any concrete phenomenon, we may perceive and understand the truth of the entire universe. There is no need to search only for a sacred location or an extraordinary event. A flower, a leaf, a grain of sand, or a drop of rain may fully reveal the principles of the cosmos. The ninth gate, the distinct yet mutually containing 10 times. The past, present, and future may each be divided again into past, present, and future. Together with the totality that contains them, this produces the symbolic structure known as the 10 times. These dimensions of time remain distinct, yet they mutually contain and bring one another into being without obstruction. In simple terms, the past has not simply vanished. It is present in the current moment through its consequences, structures, and traces. The future is not entirely absent. Its possibilities and conditions are already being formed within the present. Past, present, and future mutually participate in the reality of this moment. Consider a tree. Its present form contains the record of its past within its rings, structure, and growth. It also contains the possibilities of its future development. The 10th gate, the perfect virtue of principle and companion. Within any situation or system, when one phenomenon becomes the principal focus, all other phenomena naturally become its companions. When the perspective changes, any other phenomenon may become the principal focus, while the rest become its companions. Principal and companion may exchange positions freely, while the completeness of the whole remains unchanged. Consider a concert. When the piano performs a solo, the other instruments become its accompaniment. When the violin takes the solo, the piano may become part of the accompaniment. Every instrument may become the principal voice. Each shift of emphasis preserves the integrity of the entire performance. The universe may be understood in the same way. Every life and every phenomenon may become the center of its own world, while all other things contribute to its existence. At the same time, it also contributes to the existence of every other center. No being is absolutely and permanently secondary, and no being is eternally the sole principle. The meaning of the 6 characteristics and the 10 mysterious gates may be summarized in a single statement. All things in the world appear on the surface to be separate, independent, large or small, earlier or later, primary or secondary. At the deepest level of reality, however, they mutually contain one another, bring one another into existence, arise simultaneously, and coexist without obstruction. The whole is present within the part, and the part is present within the whole. The one is present within the many, and the many within the one. The past is present within the present, and the present participates in the future. The great is present within the small, and the small within the great. The Huayan school calls this condition the perfect interpenetration of the Dharma realm. The universe is a complete and unobstructed whole in which all things communicate and coexist without conflict. Our ordinary suffering and attachment arise in large part because we see only one side of reality and mistake it for the complete truth. The 6 characteristics and 10 mysterious gates are like 16 windows opened by Huayan Buddhism. Beyond every window lies the same infinite landscape. In summary, as described in traditional Huayan writings, the dependent arising of the Dharma realm is perfectly integrated and unobstructed. It resembles Indra's jeweled net, in which every jewel reflects every other jewel in an endless yet harmonious pattern. The universe is an extraordinarily complex network of relationships that ultimately exceeds the capacity of language to describe. The 10 gates and 6 characteristics are conceptual instruments that help us examine this network layer by layer. In the end, we discover that there is no isolated individual and no one-directional form of causation. All things share one interconnected reality, mutually depend upon one another, mutually identify with one another, and mutually interpenetrate. It is for this reason that all worlds may be contained within a single particle of dust, and that the inconceivable state expressed as the one is the all. And the all is the 1 inch becomes possible. This is the perfectly integrated world envisioned by the Huayan school. 3. A dialogue. Modern physics reveals the interconnectedness of things through experimental findings. Buddhism explains, through philosophical reasoning, how all phenomena mutually identify with and interpenetrate one another. Both point toward the universal interdependence of the countless phenomena of the cosmos and toward the profound insight that the whole may be contained within the part. In modern physics, scientists observe at the phenomenal level that exchanges and interactions among particles contribute to the formation of physical events. Things arise through reciprocal conditions and participate in chains of mutual causation. At the level of potentiality and interaction, particles cannot be understood entirely apart from the combinations, fields, and relationships through which they appear. The EPR paradox and the Foucault pendulum further suggest that any local region of the universe, however small, is influenced by realities beyond itself. Because phenomena are interconnected, information concerning the larger whole may sometimes be inferred from the behavior of a particular part. This resembles the jewels of Indra's net, in which every jewel reflects all the others and every reflected image contains further images. The ancient statement that the one is the all thus appears to acquire a concrete physical analogy. The image becomes especially vivid in holographic technology. In a hologram, the apparently inconceivable vision of the whole world contained within a single particle of dust is, on one level, given a tangible representation. David Bohm therefore argued that the indivisible quantum interconnectedness of the entire universe should be regarded as a more fundamental level of reality. Fritjof Capra likewise wrote in the Tao of Physics that quantum mechanics compels us to recognize that the universe is not simply a collection of objects, but a complex network of relationships among the parts of a unified whole. Of course, the relational picture presented by physics remains primarily concerned with the interdependence among physical objects and observable phenomena. In Buddhism, the principle is expressed through the infinite dependent arising of the Dharma realm. Every phenomenon functions as a cause and condition for other phenomena, producing a vision of the Dharma realm in which all things interpenetrate without obstruction. Physics may not yet have explained the relationship of mutual identity and mutual interpenetration as completely or as deeply as the Huayan doctrine of dependent arising within the Dharma realm. Nor can the two systems simply be treated as identical. Nevertheless, certain experimental findings and the concepts formed around them appear to reveal at least an outline of what Buddhism calls the unobstructed Dharma realm of all phenomena. The metaphor of Indra's net therefore takes on renewed vitality within the language of physics. The image of the one as the all also appears, in a striking way, within the evidence and conceptual models of science. This similarity has implications for both Buddhism and physics. In one sense, the development of modern physics offers a preliminary and concrete analogy for the Buddhist doctrine of the dependent arising of the Dharma realm. Conversely, the more complete Buddhist account of interdependence may offer a deeper philosophical interpretation of the relational networks described by physics. From this perspective, interdependence is the cause, while the one is the all, and the all is the one, is the result. This relationship reveals something about the deeper structure of the world. As a concept, interdependence rejects the view that things exist in complete isolation. It reminds us that when we act upon one part of a system, we must also consider the effects upon other parts. This awareness encourages caution and responsible judgment. It corrects a distorted way of thinking that disregards consequences and fails to understand that damaging one part may ultimately damage the whole. The insight that the one is the all also indirectly echoes the traditional ethical teaching. Do not neglect a good deed because it seems small, and do not commit a harmful act because it seems insignificant. The dialogue between modern physics and Buddhism concerning the interdependence of all things therefore does more than revive an ancient and frequently questioned proposition. The one is the all, and the all is the one. It also makes us aware that every action of mind and body may generate a chain of consequences. Reckless behavior that disregards its wider effects should be restrained by an understanding of interconnectedness. This is especially important when humanity confronts a shared environment. In matters affecting the common world, we should act only after comprehensive consideration, careful judgment, and serious reflection. Conclusion. These 3 episodes have focused on questions concerning matter. They have placed the theories and experimental findings of modern physics in dialogue with Buddhist thought, serving as an initial exploration of the philosophical relationship between Buddhism and science. The material world is unquestionably the central subject of physics. Yet the development of modern physics has unexpectedly carried the discipline beyond its traditional boundaries and toward questions involving consciousness and mind, subjects that physics had historically been reluctant to recognize. Conversely, although the material world is not the central concern of Buddhism, certain Buddhist concepts concerning matter, reality, and consciousness appear to have received some degree of support from the theories and experiments of modern physics. The conceptual revolution through which modern physics departed from classical physics has thus become an important basis for dialogue with Buddhism. This was likely an outcome that physicists themselves did not anticipate. From the perspective of physics, matter was once regarded as the totality of the knowable world. This understanding rested on 3 assumptions: objectivity, reality, and independence. Physics assumed that the world possessed an objective existence unaffected by consciousness. That matter possessed a concrete and substantial reality, and that individual entities developed independently according to self-contained laws. Upon these assumptions, physics constructed its research system and defined its intellectual purpose. These assumptions also contributed to the discipline's long conflict with religion. Yet individual consciousness, once excluded from physical inquiry, has come to be recognized as inseparable from the conditions of observation and, in some interpretations, from what is called objective reality. The substantial reality traditionally attributed to matter has also been challenged by developments within physics itself. The discovery that apparently separate entities may be fundamentally inseparable has brought about an equally profound transformation in the foundations of physical thought. This transformation has created the possibility of easing the historical tension between physics and the Christian religious tradition. More surprisingly, some of its conclusions appear remarkably close to certain central concepts in Buddhism. Regarding the influence of consciousness upon observation, Buddhism has long maintained that no phenomenon exists entirely independently of mind. Regarding the substantial reality of matter, Buddhism teaches that all appearances are illusory. Regarding the interconnectedness of individual entities, Buddhism presents the doctrines of dependent arising, mutual causation among all phenomena, and the unobstructed Dharma realm in which all things mutually interpenetrate. The relationship between mind and matter suggested by Schrödinger's cat may therefore be seen as resonating with the Yogacara, or consciousness-only, tradition. The uncertainty and probability associated with the quantum world may be compared, to a certain degree, with the Buddhist concepts of emptiness and the middle way. The relational phenomena associated with the EPR paradox and the wider philosophical interpretation of the Foucault pendulum may likewise be compared with the Buddhist doctrine of dependent arising within the Dharma realm. These parallels suggest a meaningful degree of resonance and similarity. From the Buddhist perspective, Buddhist teachings have been widely respected throughout their long history of transmission. Yet the claims that mind plays a formative role in relation to matter, and that phenomena lack fixed or substantial reality, have frequently generated controversy. Criticism of such teachings may be found among certain Neo-Confucian thinkers of China's Song and Ming dynasties, as well as among modern advocates of scientific materialism. Today, however, new discoveries in physics, reached through rational analysis and supported by experiment, appear to reveal faint outlines of these Buddhist propositions. It is almost as though the scientific method has begun to provide an initial indication of the philosophical reasonableness of certain Buddhist teachings. In this sense, some Buddhist principles have received a degree of support from modern physics. This has gradually weakened certain doubts surrounding those teachings. Modern physics has therefore become, in one respect, a scientific-era commentary on Buddhist thought. Physics can no longer be regarded as a system of knowledge entirely separate from questions of religion, consciousness, or spiritual life. After following a long and indirect path, it has arrived at certain points of convergence with ancient Buddhist teachings. Buddhism, in turn, need no longer be viewed exclusively as a distant and inaccessible metaphysical doctrine. It may also be approached as a philosophical system whose claims can, in certain respects, be examined in relation to observable experience. Still, this dialogue does not permit us to claim that Buddhism and physics are completely identical. As Huang Mingda cautioned after discussing the similarities between the wave function and Buddhist emptiness, similarity must not be mistaken for identity. The two traditions differ in their starting points, methods, purposes, and perspectives. Beyond their areas of conceptual similarity, each follows its own independent direction of development. Nevertheless, the possibility of mutual illumination and supplementation remains. Wang Shui, a professor of physics at Tsinghua University, expressed a similar view. Buddhism and physics may appear on the surface to be entirely unrelated. Some people even believe that they contradict one another. In fact, both seek to understand nature and to address the fundamental problems of human life. They differ primarily in their methods of inquiry, their areas of interest, and their points of emphasis. If their respective understandings of the universe and human existence could be brought together, their answers should illuminate and complement one another. Perhaps physics has neither the need nor the intention to prove Buddhist theory. Buddhism, for its part, has never depended upon validation by physics. Nevertheless, the significance of this dialogue cannot be denied. It allows science to begin moving beyond its role as one of the forces contributing to the modern crisis of meaning. It also allows Buddhism to move beyond the image of an abstract and inaccessible metaphysical tradition. More importantly, humanity's different modes of understanding the world appear, through different paths, to be approaching a measure of convergence. Buddhism and physics may therefore be said to describe, together, a world in which mind and matter are interrelated. Matter does not possess a completely self-sufficient substantial existence, and all things and phenomena are mutually dependent and interconnected. The recognition that matter lacks absolute substantial existence may correct the excessive elevation of material value. The interrelationship between mind and matter may encourage humanity to move away from materialistic extremes, and to reconsider the proper relationship between consciousness and the physical world. The concept of interconnectedness among material objects and phenomena reminds us that whenever we intervene in the world or alter the environment, we should proceed only after comprehensive examination and careful judgment. These three ideas reinforce one another. Together, they point toward a constructive attitude toward the material world. The value of material things is not absolute, but is defined in relation to the human mind and human purposes. We should therefore neither become attached to material pursuit nor reject the material world entirely. Instead, we should make wise and appropriate use of material things with a broad, balanced, and prudent perspective.